record and start sharing screen. And today we will start with a new topic. So we already finished a stack, okay? But today's topic maybe there may be some relationship with stack. And have you ever heard the recursive concept? Anyone heard of the recursive concept in programming language? In any other programming language at all? Has any one of you learned?
I've heard of it. I've never implemented it.
Oh, you heard it. Okay. Okay, very good. Then we are going to learn it.
We implemented it in C, in CS265.
Oh, okay. So then you got it. Yeah, then you got it. Okay. So then purely just based on the word, can you guys guessing what it is? Based on the recursive, the word, English word. And versus, generally when we discuss recursive, it's versus iterative. Anyone knows what is an iterative is? Anyone knows the iterative is? What an iterative is?
So I guess recursive is using a function and iterative is using a loop.
Yeah. Okay, yeah, quite close. Okay, so let's first see what is iterative. Yeah, just like the answer. You can put your answer to the chat. I can give you bonus point. Okay, so iterative is, we all learned loop, is it? And within the loop, each time, if the loop did one a cycle, is it? In loop, there are a number of cycles. That's within the loop. And each cycle basically is called one iteration. Is it? That's how the word iterative regarding loop come from. Okay, it's called one iteration. Okay, because later on, okay, remember, because later on we will also learn a concept in Java called the iterator. Okay, so that's how how this word iterator comes from. Okay, so it's because of the iterative is a loop, is it? And anyone can tell me so far the kind of loop we already learned? Anyone remember loop? So far, what kind of loop we have learned? Yeah, we discussed loop. Anyone can give me?
For each and while and do
yeah,
while.
Very good. Yeah, regular for loop. Is it? For loop, we call it determinate. Is a definite loop because with a fixed number of iterations, is it? So it's a fixed number of iterations. Is it? Then we have while loop. Is it? While loop, you don't need to have fixed number of iterations. Is it? That's why we call it indeterminate loop. Is it? And we also learned another one is what? For each loop. Is it? That's so far we have learned. Okay. So anyway, this all related with iteration. Is it? And you can clearly see each iteration. Is it? Okay. So that's the concept of iterative. Okay, and today we will learn is recursive. Okay, in Java, because Java we don't have function, we call it a method. Okay, a lot of other language we call it a function. Anyway, so we will learn, we call it a recursive method. Yeah, just like Alex, I believe that's what you answer. It's about a method, not a loop. So that's just generally speaking. Okay, doesn't mean you cannot. Okay, because in some scenario you may have the loop, but the loop's purpose is not related with the recursive method you write. Okay, so what is a recursive method? And then so far in a method, you can call another method. Is it? You can call another method. Is it? And yesterday we learned all of the methods in your program will be stored where? Yeah, that's another good question. Where are all methods stored?
Stack.
Yeah, very good. So that's our first quiz question. Today's first quiz question. Where are all of the methods stored? We call it what? Wrong what? Stack. Anyone remember the other word? Wrong what? Wrong time. Okay, be careful. Wrong time stack. Is it wrong time stack? Okay, why we say it's wrong time? Is it your program can be compiled? So it has a compilation stage. Is it? Compilation is the compiler is going to compile it. Is it? And then your program is running. Is it? Your program is running as instruction by instruction. Is it? That's what we call it runtime. Is it? And there is a stack. Is it a special data structure in operating system? Is it called stack? So a runtime stack, the method going to be stored there. Is it? Okay. Anyway, so here is regarding in a method, you can call another method. And we already quite familiar with this concept. Is it? So that's normal. Okay, so today it's called recursive method. Recursive method. Okay, recursive method is what? Is in a method call method itself. Call it self. Okay, so that's we never saw this. Is it? That's we never saw it. Is it? Then you just think about it. Is it if you have some function, void function? Is it? And in it, generally speaking, you call another one. Is it? You call function another. Is it? You call function another, then that function another will be execute. Is it? And then it's the end of the other function. Is it? Okay, then the program will continue. Is it? Then this function execution will be terminated. So that's nature. Is it? Okay, then over here, then just think about it. Okay. So you have this void function, and within it, you call yourself. Okay, it's a public static, suppose in Java, is it public static? Is it in Java, something like this? Okay, then in your main, here is your main. In your main, you say, oh, I call function. Just think about it. What's going to happen with this? This is called call self. Is it called method itself? Call method itself. And this is the definition of the function. Within the function, you just call yourself. Okay. So then think about what's going to happen. Anything. So in your runtime stack, this is a runtime stack. Is it runtime stack? You have main pushed. Is it because main is executed? Is it, oh, then main first call function. Is it a function? Then within this function, okay, I'm going to this function call itself. Call itself. Oh, I need to push the function again. Okay, then this go back, call itself. Then I say, oh, I call it myself. Okay, call myself, then I need to go back to myself to call. What's going to happen, anyone? See the pattern? For the runtime stack. Okay, anyone see the pattern? Can I stop here?
No.
So it will do what?
It will go infinitely until we run out of memory.
Yeah, very good. Is it? So this pattern will continue. This is kind of like a spiral, like a black hole. Is it? It's you can never see the end when the function going to be terminated. Is it? So there is an issue. Is it? But this is called a function call itself, and this is a recursive method. This is a recursive method. Okay, our second quiz question. Second quiz question is regarding our function, regarding this function, the problem will cause the runtime stack is what? So runtime stack, it will run out of the runtime stack. Is it? There is no more space for the runtime stack to take the infinity number of the function call itself. Is it? So your answer is, the issue is run out of runtime stack. Is it? Okay, so that's the second quiz. So you just send your answer to the chat. Okay, so anyway, so you know what a recursive method is. Is a recursive method is a method that calls itself. Okay, but we see the problem with the implementation of this specific method. Is it? Because it's never going to reach the end of the function call, because it just keep calling itself, and the runtime stack will just be kept piling. Is it? Okay, so that's not going to work. Okay, so regarding, so whenever you write a legitimate recursive method, there are two cases you need to consider. Okay, one is a recursive method must provide a stopping case. or we call it base case, or anchor case, whatever. Okay, oh, not a base case. So you must provide a stopping case. Okay, later on we will see in our example, okay. The second part of it is the reduced case. Okay, reduced case, it's not just call itself. It call itself with some reduction. Reduced parameter. Okay, so that's called reduced case. Because otherwise, it's even though you have stopping case, if you don't have reduced case, you just call yourself. Generally speaking, this is where the recursive happens. Okay, but it's recursive call with reduced case, because if you don't reduce the case, it will never bring you to the stopping case. Then the method will be kept calling just like the issue we discussed, okay? So keep that in mind. Recursive method must have these two cases, okay? Whenever you write a recursive method, you must check if you provide both of these two cases. Okay, then next, let's see our example, okay? The first one, okay, regarding factorial, okay. So here we have a factorial function. Factorial, everyone knows, is in math. It's 1 times 2 times 3 in this all the way to n, is it? That's called a factorial. So we are going to find the number n's factorial. Is it factorial? And in math, it's kind of, you can write n equals 1, is it? If n equals 0, is it? And otherwise, it will be what? We can write it as n minus 1's factorial times n. Is it? Times n. That's in math. Is it? So then is if n is greater than 0. Is it? In math, you know this. Okay, so basically factorial is okay. The previous number's factorial times itself. Is it? And this can be further write as n minus 2's factorial times n minus 1 times n. Is it? You can further reduce it to n minus 3's factorial. Is it? Times n minus 2 times n minus 1 times n. Is it? You can keep doing like this. Is it? Until it reaches, okay, 1 times 2 times 3 times all the way to n. Is it? That's factorial. Okay, so then let's see this factorial method. Okay, because factorial calculation grows quite quick. Is it? So that's why the return type in this case, we use long. Is it? Because if you use int is 4 bytes. 4 bytes what? Is 16 bits. Is it? 16 bits is because you are also going to support negative integer number. Is it? So we should divide this by 2. Is it? So it's negative 2 to the 15. Is it? 2 what? 2 to the 15 minus 1. Is it? Because including 0. Is it? So total number, this is total number, is 2 to the 16. Is it? So the maximum number and the minimum number it can support for the integer Is it? It's 2 to the 15 minus 1. Is it? So it has certain range, but factorial grow quite quick. Is it? Beyond that, then this int won't work. So that's why over here we use long. Is it? Long may be, I don't remember how many bytes, okay. 16 bytes or something, or 8 bytes, I don't remember, okay. But anyway, it has more digits. So the range it can support grows quite quick, okay. So anyway, this factorial method is, let's see what it says. It says, oh, if n is 0, like our math factorial definition, it says, okay, I'm going to just return 1. Is it? And if other case, if n is greater than 0, what it says? It says, okay, I'm going to write like this. It's going to be n times what? Times, you call yourself here. Call self, but with what? Over here. Over here is, you call self with reduce case. Reduce case. Is it? You didn't do that, because if you write like this, if you say, oh, that's going to be, then I'm just going to call factorial n. Will that work? That will not work. Is it? This is call itself, just like what we draw previously. Is it? Just like what we draw previously. Is it? It will keep growing and then run out of your runtime stack. So that will not work. But over here, you reduce it to n minus 1. Is it? So then let's see. So it's n minus 1. Is it? So assuming you call, okay, in main, you call factorial 5, suppose. Is it? You call factorial 5, then what's going to happen? It will not go here. Is it? It says, okay, it's equals to what? Okay, to 5 times factorial 5 minus 1 is 4. Is it? Okay, I don't know what a factorial 4 is. I'm going to keep calling. So it will be 4 times factorial 4 minus 1. So it's 3. Is it? But I don't know what a factorial 3 is. So I'm going to keep going to call myself. So it's going to be 3 times factorial 2. Is it? And I don't know what a factorial 2 is. So I'm going to call, okay, 2 times factorial 1. And I don't know what a factorial 1 is. So I'm going to call, okay, times factorial 0. Okay, when I call factorial 0, so let's see. Then in this case, is it you have main be plugged in? Is it? Then you have factorial 5 be pushed because you don't know. Is it? So it be put, and then you push to factorial 4. Is it? Factorial 4 hasn't been calculated. So you push factorial 3. Is it? You keep doing factorial 2, factorial 1. Is it? And factorial 0. Okay, when you reach factorial 0, that's the top of the activation record on your stack. Is it? Okay, then it's say, oh, n is 0. Is it? N is 0, it says it's return 1. Is it? So no more call itself. Is it? So basically this guy is done. Is it? It returns 1. So over here, you have 1 out. Is it? Okay, you have 1, then just let's see. We have this stack because the program run finished this part. Then to go back to check the runtime stack. Oh, this is the top activation record. So I'm going to pop this factorial 1 out. Is it? Factorial 1, okay, it's 1. N is 1 here. 1 says it's not the base case. It's a recursive case. So it's what? It's 1 times factorial 0. Factorial 0, you already know. Is it? It's what? It's 1. Okay, so 1 times 1 is what? Roll back, it's 1. It's 1, is it? Oh, so this function, this method completed its task. So it's out of the stack. Then you go to the runtime to check, okay, the next top one is factorial 2. Okay, so now you plug in with 2. It's not the base case, so it's go to the recursive case. So it's called 2 times factorial 1. Factorial 1, we know, okay, it's 1. So 2 times 1, so it's 2. So you have factorial 2 completed. Is it? Then on the stack, it's factorial 3. Okay, 3, then the same thing. It's going to be 3 times factorial 3. Is it? Oh, no, not factorial, factorial 2. Is it? Factorial 2, we already know it's 2. So 3 times 2, it's 6. So we know factorial 3. Is it? So factorial 3 out of the stack. Then you go to factorial 4. Factorial 4 is for it's 4 times factorial 3. Is it? So factorial 3 is what? It's 6. So 4 times 6, it's 24. So you have 24 figured out for factorial 4. And then you have factorial 5. Factorial 5 is what? It's 5 times 24. So you get it back, that's 120. So you have 120 figured out. Is it figured out? So you right now you can understand why I said when you have the recursive call, you need to do what? Reduce case. Is it? You need to have the reduced case because over here, if you plug in with n instead of n minus 1, or if you plug in with n plus 1, this method call will never stop. As it will never stop. It's run out of stack. Is it memory? Is it? So that's why you do need to have the reduced case. Okay, reduce the case. So this is the idea about how to write a recursive method. That makes sense? Okay, so our third quiz question today. So a recursive method needs to have 2 cases. Two cases, is it? What are those 2 cases? The first is what? Stopping case. Is it over here? Is it? We have the stopping case. Is it? So the second is what? It's a reduced case. So you need to write those 2 cases. Is it? You do need to have reduced case so that your reduced case can bring your method call to what? To stopping case. And when it reaches the stopping case, then it's stop. But did you see it will trace back? Is it stopping case? It's at the very top of the stack. Is it? And once it reaches, it will trace back. Trace back in runtime stack. Is it? Is it reduced with all of this reduced case call? Is it? Until it reaches the point where your main calls. Is it? So that's where your main calls the recursive method. Is it? That's how it works. So get some idea for recursive call. And definitely for factorial, it's easy to write in iterative. Is it? You just use a for loop, as if for integer, okay, I from 0, I less or equal than n, I plus plus, is it? And you do something, is it? So here is your return value equals 1, is it? And you're going to keep updating that return value, is it? With I, is it? That's how you write with iterative. Is it? So that's iterative way implementation. Is it? No, so iterative way, no call method itself. Is it? And with the recursive call, no loop. Is it? So now you see the difference between iterative implementation and the recursive implementation. Is it? Did you see the difference? It's very obvious. Is it? Very obvious. Okay, very good. Any questions so far? It looks like also, it looks like, oh, you will see, oh, it sounds easy to write, is it? And also you can see recursive code, generally speaking, it's very concise. The code looks very simple, is it? Be careful, the word is that looks simple. It's very hard to come up with the recursive function, okay? Very hard to write a recursive function. Later on, we will see, okay? So the coding regarding programming code is concise, okay? So that's a concept of recursive method. Then what next we need to understand is, okay, I maybe leave it to tomorrow, okay? So let's continue to see the next one. The next one is a method, recursive method to find the Fibonacci number. What is Fibonacci number? Maybe you all know, that's the first two numbers, 1, 1. Then starting from the third, it's the addition of the previous two. So it's 2. Then the next one is what? It's 3. The next one is going to be 5. The next one is addition of the previous 5, 8. The next one is 5 plus 8 is 13. And then 21. And the following. Okay, so that's called the Fibonacci sequence. So this is to represent rabbit family generations, population, okay. Rabbit generation population. You can see it grows very fast, is it? Yeah, so that's called Fibonacci number, okay. So how do we write a recursive, definitely for Fibonacci number, you can implement in iterative way. And it's not hard, it's pretty easy, is it? But here, let's see, how do we write a recursive way? Fibonacci number, is it? Okay, if it's the first one, you return 0, is it? And if it is 1, we return 1, is it? So this is index 0, this is index 1. Okay, index 1. And then starting from, so both of these two cases are stopping case. And you can also see stopping case is not just, it doesn't mean you can only have one, you can have multiple stopping cases, okay? And then what next? Because it's always the summation of the previous two. Is it the addition of the previous two? So that's how it comes up with the reduced case. Is it? It's the previous one and the summation of the previous two. So you add the recursive call the previous two, and you add them together. Okay, but did you see you did have the reduced case? Is it? Because with this reduced case, it will bring you to the stopping case. Be careful when you write your recursive method. If your reduced case will never bring you to the stopping case, that won't work. Okay, whenever you write, you need to think about, okay, will this reduced case to the stopping case? If it will, then that's right. Otherwise, that's not a right recursive method. Okay. So anyway, so this one does achieve the goal, is it? So it can bring it to the reduced case. So that's Fibonacci. And for, as I also said, Fibonacci can also be implemented with iterative way, okay? Okay, so that's Fibonacci. And over here it shows how do you do iterative way to write 2 to the power, is it? So you can see it's quite efficient also, is it? With iterative way, is it? So here it shows iterative implementation, is it? So you just use a loop, is it? And you each time you kind of double it, is it? And then you return it, is it? And here it shows power of 2 recursive implementation, is it? Then you have the stopping case, you have reduced the case, is it? Reduced case. So this is also pretty simple case. And what is the next one I would like to discuss? Maybe we can leave it to tomorrow. Okay, let's discuss these 2 cases. Okay, with the iterative way and the recursive way, is it? Then you may ask, we can implement this power of 2 with iterative. Why do I need to have recursive? Is it? And also, let's compare the efficiency